set there.
On this mic?
Yeah.
Okay. All right. Well, welcome everybody. This is Derek Hernan from the University of Wisconsin at CIMSS for the 1 o'clock hurricane briefing. Again, another active day in the tropics today. We're taking a look here at an overview of all the different tropical systems. We'll start over here with Olivia. So Olivia is now a tropical depression, passed through the Hawaiian Islands yesterday as a tropical storm, minimal tropical storm. I saw some gusts there to about 50 miles per hour. I haven't heard of any damage, but there was also some fairly heavy rainfall in the mountainous areas. I did see some flood warnings that were up. Look at some storm totals maybe later today. But in any case, this storm is weakening. We won't spend a lot of time on that. A couple of INVEST systems, one that's just popped up here off the coast of Mexico that the Hurricane Center is taking a look at. A little bit closer to home for us here is another INVEST. This is 95L. We've been watching this system for the last couple of days. Come across the Northwest Caribbean into the Yucatan Peninsula and now is in the southern Gulf of Mexico. The Hurricane Center has a probability of this developing in the next 5 days. I think the last time I saw it was 50%. Aircraft is flying out there now to investigate the system. We'll see if there's any observations from them. Obviously, the big news for us right now is Hurricane Florence, which is making an approach on the North Carolina, South Carolina coast. We also have Tropical Storm Isaac, which is moving through the Caribbean islands here as a tropical storm. System is weakened over the last 24 hours due to wind shear. A new storm that we have is Tropical Storm Joyce. I believe this is still subtropical. Is it subtropical when you last looked here? Still subtropical, yeah. So this is a subtropical system, not purely tropical. It's a little bit in between a mid-latitude system and a tropical system. It is expected to transition into a tropical cyclone in the next 48 hours. And then we have Tropical Storm Helene, which has weakened from a hurricane and is moving north. Interestingly, these two storms right here, Helene and Isaac, Joyce, might interact with each other a little bit as they pass close by each other and probably will induce some unusual motions in the short term. Helene is expected to race off to the northeast and actually impact the British Isles in a couple of days. So we'll go over to the Hurricane Center page and just kind of take a look at the status of the storms. As I mentioned, this is the INVEST system that they're looking at, 50% probability of developing a tropical cyclone. Getting a little close to the coast here, starting to run out of time a little bit in terms of its development. Regardless of whether this system develops or not, it will bring some heavy rainfall to the coastal Texas area, which has already received several inches of rain from a system that interacted with the coastal area there a few days ago. Otherwise, we have Florence here, again, as I mentioned, just approaching the North Carolina, South Carolina coast. Moving to the northwest at 9 knots, but I think that turn might be turning to the west a bit. We'll take a look at reconnaissance observations. Otherwise, the storm is a Category 2 hurricane, sustained winds of 90 knots, central pressure of about 955 millibars. Isaac down here, again, a fairly weak tropical storm at the moment, sustained winds of only about 40 knots, moving very quickly to the west. And that fast motion to the west is imparting some wind shear on the circulation, and that's partly why we've seen the system weaken. As I mentioned, this is Subtropical Storm Joyce, sustained winds of 35 knots, so a minimal subtropical storm. And then Helene, also sustained winds about 60 knots, tropical storm and expected to weaken. So let's just take a quick look at the official track for Florence. So this is the official warning for the National Hurricane Center. Again, landfall expected to occur sometime tomorrow morning. And then the storm is expected to slow to a crawl here as it moves along the coast, maybe just almost parallel to the coast here, right over Wilmington, North Carolina, it looks like, as a hurricane. The good news here is that the storm has weakened a little bit in the last 24 hours. Unfortunately, that the weakening of the winds has caused the wind field to expand outward, which gives us a bit of a larger tropical cyclone. So in terms of the total energy and wind energy that the storm is creating, it's about the same, actually. Otherwise, we do have hurricane warnings up, obviously, and storm surge warnings up for the coast. One thing we've seen today in the official track is not quite so much of a bend to the west-southwest. So certainly there'll be impacts in South Carolina, but maybe not quite as severe as we were thinking maybe even a few days ago. A quick snapshot here of the infrared satellite picture, just showing all our different systems. We can see Florence up here. The eye in Florence has kind of come and gone. Currently is being hidden by cirrus clouds at the moment, though it's showing up very nicely on radar. This disturbance in the Gulf of Mexico, some thunderstorms have blossomed with that near a very weak low-level circulation center. It's not very well defined, but it has become maybe a little bit better defined in the last 24 hours. Again, we'll look at the aircraft data and see if they've seen anything out there. Otherwise, Isaac doesn't look much like a tropical storm at this point. The low-level circulation is actually way over here off to the west side of the convection. Convection has been sheared away by strong upper-level winds, and there's actually a fair amount of dry air that has also worked into that area. In fact, maybe we'll just take a quick look at that product. So if we look at the air mass product, we can see some dry air kind of to the north of the circulation. Some of that's being pulled around. Again, not helping the system maintain its convection. The convection has been very bursting in nature. Another way to look at the moisture would be the total precipitable water. So here we're looking at the moisture environment. Again, this is the environment around 95L, very moist, no evidence of dry air there. Florence has been a little bit interesting. There's been some dry air in their environment, and we'll show some upper dropsondes from the aircraft that show that. And the reason that's important is that that dry air has wrapped around the south side, and the wind shear vector has been from that direction. So it's kind of pushed that dry air into the cyclone, and it's basically ingested some of this dry air actually into its inner core. We can actually see some lower TPW values at the end of this wrap into the circulation. And we've seen that on radar today as well, where there seems to be some dry air in the moat region there. Otherwise, a little bit of moisture associated with Isaac here. Again, some of that dry air wrapping around on the northwest side. And we can see these other two systems now beginning to close in their distance here between Helene and Joyce. And it'll be interesting to see how these two circulations interact. We might get a little bit of a Fujiwara interaction between these two as they kind of rotate around each other briefly, and then Helene races off to the northeast. This is the mesoscale sector zoom for Florence animation. And as I mentioned, you can't really see much of an eye here. The eye was more visible earlier in the day, but has since kind of clouded over, maybe a little bit of it emerging here now. One thing we're watching with this storm is that it is moving over the Gulf Stream at this point. So the waters are just slightly warmer here. It might foster a little bit of modest intensification, but the thing is with these really large tropical cyclones, it becomes more and more difficult to really spin up the inner vortex. Also, the pressure gradient has really spread out with this storm. So again, very difficult to tighten up the eye wall and increase the winds much. Nevertheless, I would not be surprised to see the pressure fall a few millibars and maybe the winds come up maybe 5 knots or something like that before it starts moving closer to the coast where there's a little bit of cooler water right along the shelf here and begins to upwell colder water and also interact with land a little bit. Other thing I might want to note here is that you can see that the circulation of Florence is elongated from the west to the east. And that is being caused by the wind shear from the south, kind of a south-southwesterly shear vector, which is kind of compacting the storm. And you can see it's kind of inhibiting the outflow a little bit on the south side here. But one thing I've noted in the last 24 hours is that the outflow is spreading out in this direction more than it was yesterday, which indicates that maybe this wind shear is starting to weaken just a little bit. So the warm ocean environment, the decreasing wind shear are somewhat favorable for some modest intensification. So NOAA is out there flying now, and also the Air Force, they're completing a mission into Florence. And one thing we've noticed is that you can see that the last several fixes have shown that northwest motion, but the last couple of fixes have turned more to the west-northwest. So we've been expecting this turn to occur. We expect this to continue to bend to the west as the upper level ridge builds north of the system and northwest of the system, and also for the system to slow down. And we can even see that in the fixes here. They're a little bit closer together now than they were earlier today. So the motion is bending to the west and slowing down, which was pretty much as forecast. The other thing we've noted here is that the pressures are down a few millibars from yesterday. The pressures yesterday when the system weakened initially dropped to, or raised up to about 959 millibars or so. So a little bit of decrease in the pressure here. The wind's not terribly strong. If we look at the last cross section, flight level winds, we can see a strong wind asymmetry right now with this storm. With weaker winds on the south side, stronger winds on the north side. Some of this is due to the motion asymmetry, but some of it could also just be explained by the fact that there's probably more convection in this portion of the tropical cyclone. And you can see that kind of mixing down. This is the SFMR, so this is the estimation of the surface winds. And again, we see that very strong asymmetry here. So again, probably more momentum transfer occurring here on the north side of the tropical cyclone, getting those stronger winds to the surface. The gradient's probably a little stronger on this side as well. Still seeing a little bit of a double wind maximum in the data here. So we see two peaks here on the south side, two peaks on the north side. We can also see that a little bit in the flight level data, and that's indicative of a dual eye wall structure. It appears that the system is probably undergoing an eye wall replacement cycle, but this cycle, unlike the previous eye wall replacement cycles, is probably going to take its time because of the environment, also because the outer rings are fairly large. It'll take a lot longer for these to work their way inward. So take a look at the upper level environment. So these are the upper level winds over Florence right now. We can see the outflow very well defined on the west side of the circulation, this nice outflow jet going up to the north into the mid latitudes here, and then crossing over into the ridge and then dumping that mass down here into the central Atlantic. Otherwise, the outflow, as I mentioned, a little restricted on the south side here. Again, there's an old upper level cold low sitting here right over the Bahamas. And that feature actually was helping Florence a few days ago, but now they're in such close proximity that it is imparting a little bit of wind shear on the system. And that has weakened it over the last 24 hours. Actually, this looks like a very old image. Sorry for that. Let's back that up. Here we go. That's the current image. Okay, so here's the upper level low now drifted over Florida. Again, we can see the outflow very well defined over the storm. I mentioned that wind shear from the south, but now it looks like it's kind of taken on more of a west-southwest direction here. And again, doesn't appear to be impacting the system as much. The reason I had that up is I wanted to back up to yesterday and show what happened. So this was yesterday morning, and we can see the outflow was fairly well defined. Then we can see this upper level low here. But if we step forward a little bit here, we can see that there's some stronger winds here on the order of 30 to 40 knots, basically coming into the system. And we can see that that's kind of deforming the cloud field here. So we think what happened yesterday was that this wind shear basically interacted with the system and weakened the inner core a bit and created an increase in the wind shear. Now, another way we can look at that is we can take a look at the dropsondes that were dropped from the G4 flight that did a circumnavigation of the storm. And this dropsonde here in particular was located south of the circulation. And instead of an outflow type signal, we can see we've got 30 knots of southerly flow here on these first few winds here at the upper levels here. And then, so this is just more evidence corroborating what we were seeing in the satellite imagery, that there was some increased wind shear on the system, and that fostered the weakening that we saw. Another process that we've seen, as I mentioned, is this eye wall replacement cycle. And the thing with eye wall replacement cycles is they can leave the storm a little vulnerable as they're underway. So this is the microwave imagery over the last 24 hours. We can see starting here with this AMSR2 image that there was a fairly well-defined inner core here, a little bit of erosion on the south side, but some evidence of some additional banding. And then as we stepped forward in time, we can see that the outer band is kind of wrapping around the south side here. The inner core is still eroded. And then we ended up with this structure this morning, where we have kind of a fragmented outer band and a fragmented inner core here as well. You can see this dry air that's kind of worked into the system. That definitely has also eroded the eye wall. So when you get dry air, and then you also get a shear vector that is basically moving that dry air towards the inner core, we see this type of erosion. So the system looked fairly poorly organized earlier this morning as this process was underway. But since that time, the system has tightened up a little bit. The inner core has become a little bit better defined. And we can actually see that on the radar if I can find it. There we go. So this is the current radar image, again showing the eye is actually fairly well defined at this point. Some of this erosion might be due to attenuation of the radar, but we do see some openings on the microwave imagery, so maybe some of that is real. But in any case, we can definitely see this kind of banded structure where we have this outer band that's in a fairly robust band, and then an inner core band. So again, this eye wall replacement cycle is continuing to kind of evolve a little bit. It'll be interesting to see what happens here as the system moves over warmer water. Do we get some intensification of this inner core? This entire process is going to take probably a good 24 hours to complete. And one thing we see oftentimes as storms approach the coast is we get a little bit of frictional convergence, and sometimes that can tighten up the inner core a little bit. And it's interesting that the models actually show a little bit of intensification during that time. So again, there is a little bit of an open window between here and the coast for a little bit of intensification. I wanted to mention just briefly this other INVEST system. Looks like they're getting out into that region now. So there's an Air Force mission into 95L. I'm just taking a look at the winds here. Not a lot of indication of anything terribly interesting here yet. Looks like they haven't gotten over to the center. So we'll check back with that later. Okay, let's go ahead and get into the forecast portion of this. And I've got this up so that we can see both systems. So we can see Florence, we can also see Isaac, and we can also see the INVEST here. So this is the GFS on Levi's page, very excellent site for displaying model data. And see that the system is initialized as a 961 millibar storm, a little bit weak there. Pressure is down a little bit lower than that, but we would expect the GFS to underestimate that a bit. So we'll just step forward with the forecast here. And we can see the GFS takes the system right to the coast, slows it down, shows a little bit of intensification there, pressure falling as it moves over the Gulf Stream, showing landfall just north of Wilmington and then the center passing over Wilmington and then moving inland and weakening. Now, one difference that I've noticed here is that the models in general are a lot less aggressive about this really hard turn to the southwest. There are a few members from the ECMWF ensemble that do that, but at the moment, the deterministic is not showing that. Otherwise, we can see Isaac down here in the Caribbean probably is going to weaken to an open wave and be dropped by the hurricane center, but they'll continue to track the wave. There is some interest in doing so because as the system moves across the Caribbean, if it can get into the central Caribbean and especially into the northwestern Caribbean, it would find a more favorable environment. We'll take a look at that in just a sec. Just want to back up so that we can look at 95L. And the GFS has not been too aggressive with this. It closes off a circulation, might be a 25 knot depression at the most, but again, it runs out of water when it moves into Texas at that point. Real quick, we'll look at the upper level environment with these systems. We'll back it up. So I wanted to back up to here. So this is yesterday morning. We can see the upper level 200 millibar winds here plotted, vorticity and the 500 millibar geopotential heights. So this ridge up here, which was driving the motion of Florence, is going to be weakening from now going forward. And basically the steering flow kind of collapses here as another ridge builds up to the northwest of that. Also, we can see the outflow here. And as I step forward again, we can kind of see when that wind shear was kind of getting up into the circulation here and weaken the system. But going forward, it does look like just before landfall, the upper level environment does become slightly more favorable with wind shear decreasing. Otherwise, the system over the Gulf of Mexico has an upper level anticyclone over it. So wind shear is fairly low here. So if the system could develop an inner core and kind of coalesce its vorticity, there is some possibility of some modest development. Otherwise, Isaac continues to exist in a fairly high shear environment here. But I just want to step forward because, as I mentioned, if the system gets into the Caribbean here, into the Western Caribbean, a little bit lighter winds at this point, and then going forward, we can see even into the Gulf of Mexico. Now, it tracks it across the Yucatan, but if it were to track more into the central Gulf of Mexico, there would be a much more favorable environment up there. Real quick, let's just take a look at the precip forecast because that's of interest. So total precipitation from the GFS is maxing out above 24 inches here along the coast and inland for Florence. So again, we really do think that this is going to be a rainfall story for Florence. It'll also be a storm surge story as well because of the size of the system, but we think that we'll see some tremendous rainfall amounts here. One positive aspect of the forecast is that instead of stalling the storm for many days, the models seem to be a little bit more progressive with its track. And I have not looked at the ECMWF yet, so this will be a surprise to me. And it looks like the track, let's go ahead and bring up winds. So it looks like a track somewhat similar, maybe a little bit more of a southwest jog in the ECMWF than the GFS is showing. So in terms of impacts, Wilmington is really going to get walloped pretty good here, I think, in terms of both winds, and then eventually at this point, the surge won't be so bad because the winds will be offshore, but they'll quickly become onshore at this point, and the surge will come ashore in that area. So we'll be watching that closely. And then a little bit more wind energy going into South Carolina here. But again, the ECMWF, like the GFS, does not linger the system too long in this area. So that is good news. As for Isaac, it looks like Isaac moves to the west, and the previous model run was a little more aggressive in developing. We aren't out that far, so I'll just jump to that real quick so we can see it. So the previous 00Z run of the ECMWF did hang on to Isaac and actually intensified Isaac in the Gulf of Mexico, making landfall in Louisiana, possibly as a hurricane sometime late next week. Just for comparison, was it the 00Z or the 12Z?
12Z yesterday.
Oh, I missed. So this was the 12Z run of the GFS yesterday. So we saw the GFS shows pretty much nothing, but 24 hours ago, it really liked it. So I think the story here is just that if some vorticity can hang on with Isaac, and it can get into this region, that there is a favorable environment. So it just remains to be seen what is left of that system as it moves across. So I'll shift now to the ensembles. So this is Alan Brammer's page, and he plots up these nice plots of the ensembles. So this is the ECMWF ensemble from 00Z. We can see that pretty good agreement here between the deterministic and the mean ensemble of a track. Again, bending to the west, passing pretty much over Wilmington area, and then kind of paralleling the coast here a little bit along South Carolina before eventually moving inland. My thoughts on this are, again, if the storm stays just offshore, obviously it'll maintain a little more intensity. Again, though the water here is not overly warm in the shelf area, I think we'll see a lot of mixing. Also, the offshore flow will probably promote some upwelling as well. So I would expect to see some fairly cooler SSTs here interacting with the system. So if there was some intensification here, I don't think there would be additional intensification down the coast. But in any case, the ECMWF continues to be the farthest south of the models. Some of these tracks are all the way down into South Georgia. That doesn't seem terribly likely at this point based on everything else that I'm seeing, but we'll see what the 12Z does. Contrast that with the GFS ensembles, which show nothing down into Georgia. All of its members basically moving almost due west here, maybe a little west-southwest jog, but due west into South Carolina, North Carolina. And then again, nice to see actually this parabolic track back into the mid-latitudes. We really want to get this system out of here.
It looks like fast.
Yeah, much faster than it was previously.
Didn't the EC show a much more compact ensemble yesterday, and GFS was broader?
That's a good question. So the question is that the spread in the ensembles seemed a little tighter yesterday for the ECMWF, which has more members. We can take a look at that. So this is 12 hours previous. This would be the 12Z ensemble from yesterday. So again, a fair amount of spread here at the 12Z. I don't think I can go back that far. I'll go back here maybe. Yeah, so when the motion was fairly steady and the steering flow better defined, we had a good agreement here, and then everything falls apart when the steering flow kind of collapsed here. It is interesting to see, this much spread in only a 48 to 72 hour forecast. But when a storm is moving fairly slowly and the steering flow is weak and fairly complicated and very subtle features are moving through this ridge here, I guess it's not too unexpected. Okay, we'll just take a quick look at what is going on with Isaac here. So this is the ECMWF. Again, was at 00Z anyway, was one of the few models that developed Isaac into the Gulf of Mexico. And we can see that there are a number of members, maybe 20% or so, that do develop this system and intensify it coming through the Northwest Caribbean and into the Gulf. A couple of these members peel off to the north. The Navy's NavGym model also does this. But I will say that the models have been trying to do this with Isaac for many days, and it hasn't seemed to want to do that. So the reason for these tracks is that there's a fairly strong upper level trough that drops down. It's actually the trough that weakens the ridge that's causing the steering collapse near Florence. That trough drops down and breaks the subtropical ridge north of Isaac, and that's why we get some of these tracks. And then some of them get captured by the trough and race off to the northeast. So I guess we can consider this an alternate scenario, but at the moment, the primary scenario is a shallow steering flow for the system, at least into the central Caribbean and maybe northwestern Caribbean, which should keep it moving to the west and west-northwest. The ECMWF or the GFS members, not nearly as aggressive with the intensification here, just showing basically a weak system moving to the west with no development in that region. Okay, I think that's really all that I have for today, unless there are any questions. Jamie, do you want to talk about anything today, or?
I had some things up, but I think you pretty much hit them. I mean, the storm surge, we were looking yesterday, there was a narrow band there, about 15 feet of storm surge. Because of the wind field coming down, it's now down to about 9 feet. So the storm surge is certainly far better today than it was yesterday. The other thing about the rainfall, it's interesting, the QPF product for 7 days is a little different than what you see in the GFS in terms of 20+ inch rainfalls. And so I've been kind of tracking, there's been a lot of conversation about this, how close is this to Harvey? Certainly Harvey had a far larger area of 30 and 40 inch rainfall totals, but when you look at the area covered by 20 inches, it's about the same in terms of what the QPF has. And when I overlaid that area, it was almost the entire state of South Carolina for Harvey. So, but if you look at the GFS and 20 inch rainfalls, that's actually pretty similar. So it's a little bit different than what the official QPF forecast is having for Harvey. Certainly all the gauges that we have forecast information on are forecast to be at major flood stage, with a number of them likely to hit a record flood stage in North Carolina.
Yeah, Levi's page doesn't really allow us to look at the details of the precept, so I wanted to bring this up. It looks like 31 inch totals are the max in there.
Yeah, so basically
35 inches.
Yeah, and so Harvey would have 20 inch and higher would have been basically this all of South Carolina.
This whole area here.
That's 20 inch and higher.
Okay.
And in Wisconsin, that's basically La Crosse to Sheboygan and south.
Okay.
Was covered in 20 inches.
So the aerial extent of the heaviest rainfall in Harvey is larger than what we're expecting.
It's still about 6 times larger.
It's interesting because Harvey was not a large tropical cyclone, and Florence is larger. So I'm wondering what to think about that a little bit as to what the reasoning was. Maybe the
it did sort of meander a little bit, right? So and I think that was part of it. And the bands sort of were able to work around that large area.
So really the storm motion and the meandering. Yeah, this one doesn't meander. It had meandered initially, but it looks like it's going to be more progressive now.
But certainly, like I just illustrate the fact that the gauges are all forecasted to hit major flood stage. So,
right. No, this
I mean, it was
still not.
It was unprecedented.
It's not good news.
Yeah, still quite a lot of stream flooding. And then in terms of damage, what's interesting, I generally don't do damage calculations until the about 48 hours out because they can vary so much. And Derek's been giving me some. I've been doing a little bit of ensembling, but it's interesting because the wind field widened, but the top winds have come down. The damage is about the same.
Right. And
so yesterday I was calculating in terms of wind damage about $9 billion, $8 billion, and it's about the same today, about $7 billion in wind damage. Certainly the storm surge damage has come down quite a bit.
Right.
So it's half of that now.
So for those who might not have heard that, this discussion is talking a little bit about how Florence, the sustained winds are down from yesterday, but because the storm is larger, the damage potential of the storm hasn't changed significantly. A little less surge, but in terms of aerial damage.
Yeah. The wind and the rainfall, which are going to be major components, right? Those are still holding up to be about the same in terms of the damage. It'd be the storm surge sort of in those coastal areas that's come down some.
Right. And that makes sense. Any questions online?
Nope, I asked and no one said anything. So.
All right. Anything else?
One more. Is
Yeah.
it typical to have the GFS so much narrower?
You,
Connected than the EC?
you have fewer members, so that could explain part of that. I think if you have more members, you're going to get a little more variability there. I think the steering, if you look at the deterministic, it's a little more progressive than the ECMWF is. So it seems to be showing a more of a progressive flow for the system, whereas the ECMWF seems to be indicating a little bit more of a erratic motion before it continues off to the northwest. So, and that seems to be borne out in the ensemble members showing those southwest tracks and then a slower track kind of in some of those even into Georgia there. But,
It was not in general a typical thing.
no, I'm not sure you could chalk it up to one model or the other. Again, other than the fact, that the number of members is different between.
What about the new GFS?
Oh, that would be fun to look at. Sure, why not? Let's look at new
Since
GFS.
the old GFS is going away.
Yeah.
The differences between the two ensembles, while you pull that up, is if you're sitting in South Carolina, it's pretty straight. It's not a small difference in the.
Well, the first thing we see is that new GFS does not like Isaac.
South Carolina emergency management folks are lots of messaging to people, that the forecast for South Carolina is still uncertain.
Right.
That's a
I'm
good.
getting those in my Facebook feed.
Yeah,
So-
it's a good message. And the problem that we have, when we talk about the Saffir-Simpson scale, is it doesn't really convey the individual threats very well. And when people see those numbers fall, oh, it was a category 4, now it's category 2, we can let our guard down. But yeah, we always struggle with that in terms of the fact that it says nothing about the rainfall potential. So new GFS, right along the coast, looks very similar to the operational GFS. Very similar. And again, not doing much with Isaac. It does hang on to the vorticity down here, but it looks like it just takes it into the Yucatan and weakens it.
Did the operational GFS go south of west?
It was more west. It's a bit of a southwest jog there, right there at the coast. Yeah, or just for like a few hours there, and then it takes it in. So there's a little bit similar in that. Maybe the FE3 is a little more aggressive in that turn.
Well, it's good to see that they're consistent now in the shorter term since they had the same physics. Before,
Yes.
before they were really divergent.
Right. They were very divergent. And we saw some really funny behavior with that with hurricanes earlier in the year. Looks like it goes all the way up into the Ohio Valley at this point. And then we get a system off of, well, that's going to be an interesting forecast too there. An extended East Pack. We'll save that for another day. Okay, anything else?
Thanks.
All right, great. Thank you.
Thank you.
Appreciate it. Thanks everyone online.
Great.